today's lecture is about module 1.2 and we will work on arrays in this lecture. Now I should start it with arrays, which are the most powerful aspect of MATLAB. So in this particular lecture we will learn building arrays, we will learn Kotlin notion, and then we will go on array operation and function. I would suggest you to also you should watch videos on MATLAB website working with arrays in MATLAB. The link is provided in below. So we should start our today's lecture. Before we go into our MATLAB software, I would like to show you some valuable information. So first we have to learn about building arrays. So I think I should go under the so as you can see, there is a workspace and there's a lots of variables also already represented here. So first we have to clear them, clear all. Now we will start it with very refresh rate. Okay, so let the function works on it. Okay, so here we're going to start it. As in the previous lecture we learned to how to make a vector, a row vector basically, which is, let's recall that we have 5, 8, 7 and square bracket close, and then we may enter. As you can see, we got an row vector as well as we can also write a b variable which has basically a column vector. So 8 semicolon minus 2 semicolon and 7 close bracket. Now enter. So as you can see in the workspace window, these all a and b got allotted their respective values, which we all got in command window. Now coming to the today's topics, we will first write how to build arrays. So in that two particular examples, in B and in A, in that particular we already know how to build an arrays. These are also called as arrays. So now we can also build arrays by the previous arrays also. Likewise, if I have, let's say I have an variable d, I will assign it value eye. EYE is basically it is a operation. It is a mathematical operation to find a identical matrix. So I want an identical matrix of, let's say 3 by 3. I want an identical matrix of 3 by 3. Now enter. As you can see, it allotted me an identical matrix of 3 rows and 3 columns, and it also got assigned its values in variable b. Now how to build a new array by using exiting arrays. So let's say we have another variable e which has square bracket. Let's say we have a is a row vector. I previously defined it. It is a row vector, comma, and we have d. D is what? D is basically an identical matrix. Now close the square matrix, and now as it gives us a array. Array is what? Dimensions of array being concurrent are not consistent. So we cannot consistent it. Why we cannot consistent it? Because we have n row vector. Okay, and this is a square matrix of singular. So if you want to give it, basically let's say write with other thing. Okay, so we have, okay, so we will take now b. B is a column vector and d. Okay, so as you can see, as we got entered, the elements of b got allotted. Like this is the 8 minus 2 and 7, and as you can see b is also is about 8 minus 2 and 7. So it is nothing but the E is nothing but the A 3 times 4 double of identical matrix. Basically we are creating and we are building a new array of this. Okay, so now we will learn. um, okay, so we have its function. Now what if I want to this, now this is an array. Okay, and now if I want to write or if I want to know, and it's also got assigned in a new variable e. And what if I want to write which has 3 rows and 4 columns. Now I want to find the value of this, or basically I want to find this 8 in a particular matrix. So we should start it. We just nothing to have to do, we just write it down. Okay, we are on e. We will not use the square bracket, we will use a circle bracket, one row comma one column. Okay, now enter. As you can see, we will got the values of first row and first column of matrix E. As you can see, we will now, if I want to know this particular one's position, so I will write 1 E. Okay, it is second row and third column. So as you can see, it also gives me an 1. Now what if I want to write, if I want to know these two particular, sorry, what if I want to know these two, 2 and minus 7? We will do it in the next topic, which is column notions, which is basically column notions. Okay, we will build it. Okay, so okay, so as you can see, we will also try to learn the functions or the operations that we can do on an array. So as you can see, we already had a row vector which is A. So if I want to write its transpose, let's say its transpose will be A dash or A prime. So let's write it down, the A prime. So it is the A prime. Let's try to enter it. So the A dash or A prime now is becoming a column vector, right? So now as you can see, first we, on the first example, we got an error that was just like E. It was like let's say the function f, is equals to A comma D. I would like to call D is an identity matrix. D is an identity matrix. Okay, just correct it. Give us an error which is horizontally alignation. And what happened if I write f is equal to square bracket a prime comma d. So as you can see now it gone work. It gone already worked. So by a prime we can just convert. It is also known as the transpose of a matrix, as well as now we want to know what is B. B is a column matrix. I would like to know its transpose, so I simply write give a code B dash and then hit enter. And now as you can see it got converted into the B prime, which is a row matrix. So as you can see, let's write it down. So we have the D as a identity matrix of 3 comma 3. Now if I want to know the D 5 comma 5, as we know it is a 3 times 3 matrix which has 3 rows and 3 columns, and I want to know the element positioning at 5 row and 5 column. As you can know it exceeds its limit, and when we go to enter it gives us an error message. Okay, so it will give us an error message which we're going to just coming out. We will get it very soon. It is called me an unrecognized function or variable D. Okay, so let's recall an variable E. As you know, we have variable E with 3 row and 4 column. And if I want to know E square bracket 5 row and 5 column, it also gives me an unrecognized function or variable E. So what? And we can also find the size of any error function or any matrix. If I want to know, let's say if I want to know size of, you can simply write size of any row, like we have a row A. So it says me a row has 1 column, 1 row and 3 column. We have 1 row and 3 column. let's say it is answered or not. Let us say it is answerable or not. Let's recall the A function. So as we can see, it has first row and three column, right? Okay, so we have to write it down the function. Okay, so as we can see, we will also try to learn the functions or the operations that we can do on an array. So as we can see, we already had a row vector which is A. So if I want to write its transpose, let's say its transpose will be A dash or A prime. So let's write it down, the A prime. So it is the A prime. Let's try to enter it. So the A dash or A prime now is becoming a column vector, right? So now as you can see, first we on the first example we got an error that was just like E. It was like let's say the function f is equals to a comma d. I would like to call d is an identity matrix. D is an identity matrix. Okay, just correct it. Give us an error which is horizontally alienation. And what happened if I write f is equal to square bracket a prime comma d. So as you can see now it gone work. It gone already worked. So by a prime we can just convert. It is also known as the transpose of a matrix, as well as now we want to know where it is B. B is a column matrix. I would like to know its transpose, so I simply write give a code B dash and then hit enter. And now as you can see, it got converted into the B prime, which is a row matrix. So as you can see, let's write it down. So we have the D as a identity matrix of 3 comma 3. Now if I want to know the D 5 comma 5, as we know it is a 3 times 3 matrix which has 3 rows and 3 columns, and I want to know the element positioning at 5 row and 5 column. As you can know, it exceeds its limit, and when we go to enter it gives us an error message. Okay, so it will give us an error message which we're going to, just coming out. very soon. It is it is called me a unrecognized function or variable d. Okay, so let's recall an variable e. As you know, we have variable e with 3 row and 4 column. And if I want to know e square bracket 5 row and 5 column, it also gives me an unrecognized function or variable e. So what? And we can also find the size of any array function or any matrix. If I want to know, let's say, if I want to know size of, you can simply write size of any row. Like we have a row A. So it says me a row has one column, one row and 3 column. We have one row and we have one row and 3 column. Let's say it is answered or not. Let us say it is answerable or not. Let's recall the A function. So as we can see, it has first row and 3 column, right? Okay, so we have write it down the function. We just completed our first topic, which is building arrays. So now coming to the next topic, which is column notions. Column notions is nothing but the so column notion is nothing but the going to from any endpoints of two ends. Okay, so let me take the examples. Okay, so coming to the MATLAB, and if I route the square bracket 1 colon 5 square bracket close, as you can see that it gives me an increasing value of 1, 2, 3, 4 and 5. So basically what columns gives us? Columns gives us the intermediate elements of any endpoints. Okay, so we will also use it in our matrices also. Okay, that the column is always give us a column row vector. Actually it gives us a row vector, so we have always assigned it to a variable. Let's say z is a variable and we have 1 colon 3, so it gives us a row vector. And if I want to write it in 3 steps, okay, we want to write in 3 steps. So let's say y is a new variable which has assigned it variable, so 1 semicolon 3 semicolon 5. And so what will it give me? It give me first guy will first compute this with 3. So first guy will be 1, second guy will be 1 plus 3 which is 4, and third will be 1 plus 3 plus 1 plus 4 plus 3 which is 7. 7 will go beyond this 5 and which is not be visible. So when we got enter, as you can see, it will give a 4 and 5. And y is equal to, I assigned it a value right now. Let's take 2 semicolon 1. So as you can see, the first guy 2 is a greater than the second guy 1. So what would happen? Basically, we want to know what is the intermediate between the endpoints 2 and 1. So it will give us nothing but a blank matrix. So when we call enter, so it will give us a 1 row and 0 column, basically a empty matrix. Not that the MATLAB is not giving us a error, it gives us an empty value vector. You basically write it down by, let's say L is a new variable which has, we do not assign it any value and just put the square brackets. So as you can see now, has the new L has the new empty matrix. Okay, so let me clear the screen. The column notion has finished. Now we have to move on the next topic, which is array operations and functions. In previous topic building arrays, we know how to detect and position of any element in a matrices. So if I want to know positions of multiple elements, okay, so I want to know position of multiple elements. Now I recall a matrix F. So here you can see I want to know the size. I want to know the size of this matrices. So simply I would write size of F and then end. So it has the 3 rows and 4 columns. So how to use notion to find out the multiple elements position? So first of all, we have to write the which matrix we are using. We are using first F matrix, and now let's say square bracket. Now we want to find out the second row and we want to find out this particular element's position. So it is in second row and second and third column. So we will write down the second row and second column 3. It will basically give us the position of second row and second column and third columns elements. It is giving us an error. So it doesn't matter. Sorry, we will do that. Okay, so F. Okay, so find out. We will have to find out second row and second column third. So as you can see, it gave us the elements of this matrices. Likewise, we want to know the position of this particular 8 and particular 7's position. So we will write F small bracket. It is in second row column, third row, and in first column. Okay, so as you can see, it gives us the position or the values of that particular columns and rows. It is 8,5. Okay, so in general we can also, let's take the recall the matrix F, and in general we will also know F P comma Q. So where P is the query in row and the Q is the query we want to know, or we want to know query in column. Likewise, if I want to know 3 comma 3, which basically I want to know the information about third row and third column. If I want to enter, it gives me an answer 0. Likewise, if I assigned p is equal to 3 and q is equal to 3, and now I want to know the p comma q. It will also give me answer which is 0. Now if I want to know the position of, I want to assign it let's say another let's say 1 comma 2, and it assigned it, okay, and I assign q is equals to 3. Okay, now I want to call f p comma q. So it would basically give me an element. Well, let's recall the element. So what would happen at here? I assigned p the first row and second row, and q the third column. So what would happen when I calling the elements of matrix F? First, what is executed? P, which is the first row and second row. So we have the first row and second row of F, and in the next we want to know the information about Q. Q is basically a third column. So we have the first row and third columns elements, which is 0 and 1. So we have 0 and 1 at here. Likewise, if I want to know the submatrix, basically submatrix, let's say 2 semicolon 3 and 1 semicolon let's say 2. So okay, it gives an error which is expression invalid. Check for multiplication operator missing for unbalanced dimensions. Okay, so clear that all. Call the F matrix, and now we want to find out, likewise we want to find out let's say 1 semicolon 2 and 2 semicolon 3. So it gives an explanations variable. So sorry for my mistake. Let's call this matrix F, and let's call the 1 semicolon 2 comma 2 semicolon 3. As you can see, we got first row and second row, which is first row and second row, and second row and third, sorry, second column and third column. So first row and second row, and second column and third column. So this is what we will get. This particular thing we will get 1 0 and 0 1. So at here we got 1 0 and 0 1. Conclude our ending of this lecture, and the other part of this lecture, part 2 of module 1.2, will be covered into the next lecture. Till then, goodbye. Thank you.